Hello, everyone, and thank you for joining today. My name is Adam Jacobs. I'm a solution architect here at Qlik. I'm going to show you the steps I took to utilize publicly available data to create a Qlik application around the opioid crisis. But first, I want to make sure that I level set everyone here on what makes Qlik different than any other analytics tool on the market today, and that is our associative experience. All other analytics tools on the market rely on queries in some form or another, and this is an old and restrictive way of conducting analytics. What I'm going to show you here is the difference between the two. So up top, we have our associative model and our associative experience. Down below, we have the query-based tools and their experience. So let's go ahead and start making some selections. I'm going to go ahead and select Alabama. I'm going to select the first county here. I'm going to select dentist as a provider specialty type, and I'm going to select the top provider right here. Now, we're already seeing some differences in the query-based tool. I'm only seeing what I've selected and what's associated with those selections. I am not seeing any other values. With Qlik, what I'm seeing are my selections in green. I'm seeing my associations in white. And then I'm also seeing what's not associated in gray, and then alternative values in light gray. So already I have some insight here that I couldn't with the query-based tool, and that is that this particular provider also has an office in Elmore County, Alabama. That is totally hidden from me in the query-based tool. Let's continue on here, though. What I want to do is I want to say, okay, let's look at this particular drug and see what other provider types are providing this drug. Well, with the query-based tool, so far I'm still restricted on the selections that I've made, but with Qlik, I can see that family practice and internal medicine also prescribe this drug. So I can just go ahead and quickly pivot my analysis to see who these providers are within these two provider specialty types. I couldn't do that with the query-based tool. I would have had to back out entirely and try to figure that out. Another example, if I go ahead and clear all my selections here, I want to see which states do not provide this particular drug right here. Well, all I have to do with Qlik is just select that drug, and the gray tells me which states are not providing this drug. But in the query-based tool, all I can see are the states that do provide that drug. This is an example of the power of the gray. This is what makes Qlik so powerful to all of our customers, and it's why it's a complete analytics platform that allows you to see the whole story within your data. So before we go into exactly how I built out this application, what I want to do is I want to demo the application for you so you have a understanding of what it is that this application actually contains. So on this first page here, we have some impact rates analysis. The map over here is colored by opioid hospitalization rates per 100,000 people. And of course, we have some numbers here indicating what some of the aggregate information is across all of these states. And right now, this is aggregated, of course, across all the years that are in this data. So what I want to first do is I want to cycle through the years that we brought in so that I can see just the areas that seem to have increased the most in years past. So let's go ahead and hit play here. We're going to start with the year 2005, and every 4 seconds, this is going to update to the next year. So we're seeing right now that, again, this is a pretty blue map. The KPIs are pretty low. And as the years go on, at first it starts slowly shifting towards the red, but coming up in around 2010, 2011, it starts shifting into the red significantly, especially in the Northeast, as you can see. By the time that we're going to get to 2014, the Northeast is going to be mostly red and orange, which to me says that this is the area that we need to focus on as far as how things have gotten pretty bad. So my first thought is, well, I wonder what impact opioid prescriptions have had on these areas. So I've created a heat map here that I'm going to make visible that will show the concentration of opioids being prescribed. And as I suspected, there's a high concentration of opioids being prescribed in the Northeast, which seems to correlate. So now my first thought is here as well. Well, I wonder just how detailed we can get on this. So I'm going to go ahead and I'm going to select region 3 since this is the area that I happen to live in. And I'm going to look at this area, and what I notice is that while we do have heavy concentrations in Philadelphia, in Baltimore, and even in Washington and Pittsburgh, there's a whole area down here in the Appalachians where the rates are very red, but we don't have a high concentration of prescriptions being written. So I'm curious about this. So what I'm going to do, I'm going to select this area, and I'm going to select it for further analysis. So if I go to my next sheet here, now I'm getting some information on the providers that are in this area. First of all, there are 3.6 thousand providers prescribing opioids, and they're prescribing 700,000 days supply of opioids per 100,000 people on average, whereas across all providers in all states, the average is about 35,000. So already I'm seeing that maybe it's because this area is just not very populated, and that's why it didn't show up on the heat map. But the rates of prescriptions being written are really, really high. Well, we have some providers here that we can drill in on. So I'm going to just select the top providers here that I notice are popping out at me due to the high rates that they're prescribing opioids. And as I can see, this definitely correlates with the areas that happen to be the worst. In fact, these shapes are showing 60-minute driving radiuses to these particular providers. And what I can do is I can even drill in a little bit more to some of these providers and see just how much they're providing. So this particular provider is prescribing opioids, 362,000 days supply of opioids prescribed per 100,000 people. This one over here, even worse, 2.85 million days supply of opioids prescribed per 100,000 people, blowing away the average across all states and all providers. I can even actually drill in a little bit and see exactly what they're providing. So I can look in to see, are they providing significantly more fentanyl or morphine than the average provider. And if I drill into those, now what I can see is I can see that, well, yes, those certain drugs happen to be at an average rate of 3.8 across all providers, but this provider is providing 311,000 per 100,000 people. And even some of these others, I can see exactly how they stack up as well and where they fit in to those numbers, and they're all pretty high. So now that I have drilled into this information, what I can do is I can come over here to my details sheet, and I can see what they're providing. I can see the rates. I can see who these folks are, where they're located. If I want, I can deselect the drug name to see all the drugs that they're providing. Maybe I'm not interested in their street address, so I can get rid of that. And maybe what I want to do is I want to see the rate prominently over here. But this is an example of how Qlik can be used to take multiple data sets together and be able to drill into information, explore information freely to understand what's going on and provide some insights. Okay, now that we've seen the application, let's talk a bit about the data sources that were used. So these were the main data sources that I found. A couple of things that I'd like to point out here. To start, Qlik has no problem whatsoever integrating multiple data sources into a single application. Our associative model and ETL capabilities make it very easy to bring in as many data sources as necessary for analysis without the need for a third-party staging software or to load all the data into a single source, such as a data warehouse, for instance. Qlik also compresses the data on ingest, and a perfect example of this is the CMS data. When I downloaded this from the CMS website, one file was more than 3 gigabytes and 24 million rows of data. which is actually too large to open into an Excel file on a standard laptop. So Qlik was able to handle that without issue, and because the Qlik solution compresses the data, the entire application is actually about 1/5 the size of the original CMS data set that I pulled. I mentioned Qlik's ETL capabilities, which actually came in handy when dealing with the healthcare cost and utilization project data. So the format was not very analysis friendly, as you can see by the years each having their own column up here. So ideally what you want is to have a single field for year and then a single field for the hospitalization rate. So instead of needing to clean up this data before bringing it into Qlik, I was able to apply a simple function in Qlik to unpivot the table and create those two fields very easily. I also was able to use Qlik Geoanalytics to generate data. So in this case, I was able to generate the 60-minute driving radiuses that you saw in the demo for over 33,000 data points. The end result was a data model that looked like this. These data connections are not one-to-one or one-to-many, but many-to-many. This is part of that associative experience we talked about at the beginning, and it is what allows me to see how a field or a value in this data source over here, for instance, affects a field or value in a completely different data source without a query, which is completely unique to Qlik. I'm going to start getting into some topics that are a little technical now, but they're hugely valuable to this application and to our customers. I'll start with QVD files, which stands for Qlik View Data Files. In many instances, loading data into Qlik directly from data sources is perfectly suitable, as we can see here. But there are a few cases where QVDs definitely come in handy. One, for instance, if you need to regularly bring in updated data, QVDs allow for incremental data loads of just new data instead of reloading all the data. An example would be bringing in the next month's financial data, for instance. They're also useful for loading in data very fast, which is particularly useful if you are using our ETL layer to do many data transformations on ingest. This is how I use QVDs in this particular application because of the data transformations I needed to do that took place and the size of some of the data sources as we just discussed. And they can also be used across multiple applications in your environment to maintain a single source of truth and maintain data governance. So the way you actually create QVDs is you create an application that actually serves just to generate QVDs, a QVD generator app. This app contains all of the data transformations, but none of the data. The output is an efficient data source that can then be loaded by your main application, sometimes only in seconds. The best part is that it's very simple to create. In your QVD generator app, once you've created and transformed all of your various tables you will use, you simply add a couple of lines of script like you see here. Okay, so what this is telling Qlik to do is to loop through the application, and for every table that it finds, create a QVD with that table name and store it in this particular path, which is simply a folder on my computer. And then, to keep the size of this application as minimal as possible, you just tell Qlik to drop all of the tables after it's done that. Which means that no data ends up getting loaded into this particular application. The QVDs are actually then stored in a folder like this, and then what you're able to do is you're able to use another application to load in each of the QVDs like this. Right? And then your analysis app has all of these transformed data files that you don't need to do any transformations here, which just makes things more efficient and allows you to load data much, much faster. So we already mentioned Qlik Geoanalytics and how I was able to generate a driving radius for 33,000 data points in my application, and that was on the back end. However, geoanalytics was also the technology behind the maps on the front end of my application as well. So geoanalytics is an add-on feature to QlikSense and QlikView, and there's a good chance that many of you on this call have not worked with geoanalytics before. It exists as an extension in Qlik and functions a little differently than the native maps that QlikSense provides. So let me show you how to create a multi-layer map using Qlik geoanalytics. So first thing I'm going to want to do here is create a new sheet. We'll call this geoanalytics. Open it up, go into edit mode. Geoanalytics exists under the extensions folder in my edit mode here. So you can see there are a number of geoanalytics extensions. The one you always want to bring on first is a geoanalytics map. And then what you want to do that's different than in QlikSense is instead of dragging things, dimensions, measures, things like that on top of this map, we're actually going to drag these different layer extensions into other areas of the sheet. But geoanalytics automatically understands that these are extensions that are tied to the map that's on the sheet. So for instance, if I go ahead and I add dimension, we'll make this state abbreviation. We're going to go over here. We're going to change this to United States. Now we see that Qlik geoanalytics has generated a map of the United States. Of course, this is only interesting if it actually shows us something as opposed to just each individual state. So let's go under colors. We'll change this to by measure. And let's add in opioid hospitalization rates. We'll make it an average aggregation. And let's hit apply. And we'll change this to divergent gradient. So this is already looking very similar to the map we saw early on in the demo. So let's add another layer to this. Let's go ahead and add a chart layer. So if I go in here to chart layer, we'll add the dimension state so that it knows where this is supposed to go to. We'll add the dimension provider specialty type. We'll add the measure of number of days supply of opioids. And so that's going to generate that layer. We need to make sure, again, that this knows that it's United States. And so now once we do that, now we have another layer where we're seeing information for each of the states in this map. So we can look here and hover over any of these and get some information around some of the provider specialty types and the number of days supply of opioids that they're prescribing. So finally, you may have noticed that earlier on when I was showing the application that I was able to embed some Qlik charts into the info bubbles that pop up in Qlik geoanalytics. So I'll show you that again for those that may have missed it. If I hover over this, these are actually Qlik charts. One's a pie chart, the other is a KPI that's embedded directly into the info bubble in this Qlik geoanalytics chart. So I want to make sure that I leave you guys with exactly how to do this too, because it's actually pretty interesting, I think. What we'll do is we'll put this link in the chat window, but there's a community post by Patrick Nordstrom that goes into exactly how to embed charts into a Qlik geoanalytics layer. So for those of you that do end up getting Qlik geoanalytics, you can utilize this to create some of your own really powerful looking info bubbles when you're utilizing Qlik geoanalytics for your analysis. And finally, I want to make sure that we also send you the link to this opioid app. So that will also be in the chat window as well. If you have any questions at all, please feel free to reach out to me. But of course, we're going to do some Q&A right now. So I'm going to pass it back over to Jesse and Adam. So take it away, guys.